Stone facings are the next element of polygonal complexes. They are constructed using single-row masonry and, from the perspective of modern construction, represent a typical retaining wall designed to prevent soil from sliding down slopes. However, in the case of Peru, this purpose is not always applicable. Often, there is a rocky outcrop or mountain massif behind the facings. There is nothing to erode there, nor is there anything to protect from landslides. There are no roads or paths. Moreover, such facings always lean toward the base, giving the impression that the wall leans in the rocks or embankment. It is evident that facings served a different role, or even several. First, those located in the periphery of the complex. They seem to separate the structures from the surroundings, indeed preventing slope erosion along the way. Examples of such facings can be seen in Pisac, Machupicchu, or Picara. Second, facings occupy central positions and may house niches. In some cases, this type of facings encircles an elevation, forming a platform. These resemble a building turned inside out with its niches exposed. Technically speaking, that's precisely what they are. Platform niches are large, resembling false doors. Sometimes, a building combines both options, external and internal niches of different types. This case is exceptional and becomes understandable in constructions like Tampamache. The purpose of such structures is to create space for niches. The case of Huaytara amazes with its perfection achieved through maximum space utilization. However, the question arises, why wasn't this principle applied elsewhere? This leads to a paradoxical conclusion. If possible, a platform is created where niches are made with single-row masonry, and the wall gains additional support from an embankment with niches facing outward. Otherwise, a building with double-row masonry is constructed with niches facing inward. In both cases, the walls serve the same purpose, accommodating niches. It is worth mentioning Stella Nair's work, which attempts to reconstruct the appearance of the Pumapunku structures. A key element uniting all the blocks is the niches of specific dimensions. This creates direct parallels with Peru, though executed in a completely different manner. Platforms may exist without niches. For example, the masonry of Inca Roca represents a platform whose height did not need to be increased, making it a completed structure without being utilitarian. To make it functional, the walls were extended naturally in a different style. This explains the unfinished masonry in the center of Cusco. It was a platform not intended for practical use as a foundation for buildings. A seeming contradiction is resolved. Resources and skills for working diorite were sufficient for creating several extensive rows of masonry on the outskirts. Yet in the city center, construction was abandoned. Another question is why the creators did not focus on aesthetics. Having invested effort into creating impeccable joints, they did not meet even minimal aesthetic standards. The Incas plastered their buildings to give them a neat appearance as much as possible. Yet in the capital center, the walls were left as they were. Thus, facings are a structural element intended for various purposes. It's worth noting that the requirements for joint density were lower for slope protection and space separation. However, this did not affect durability or strength. Conversely, buildings and platforms were constructed with maximum precision and fitting. The difference in execution speaks of priorities. Precision fitting has an explanation beyond aesthetics, which will be described in the section on construction rules. The third function of facing, creating terraces. Not all terraces serve agricultural purposes. For example, the zigzagging facing in Pisac or the zigzags of Sacsayhuaman are difficult to associate with agrarian functions. The first is directly in contact with the rock and lacks any fertile soil layer, while in the second case the costs are disproportionate to the results. Moreover, zigzags significantly reduce the usable area. Nevertheless, zigzags can also be observed in Zone X and other complexes. This suggests that such a shape was deliberately employed. But for what purpose? The question of fortification does not apply. In places like Pisac or Zone X, such walls cannot be considered as defensive structures. This form is justified only in situations where maximum length must be accommodated in a confined space. However, implementing a zigzag is not always possible. On a mountain slope, the shape is dictated by the surface of the rock, where zigzags are minimal and simplified step ledges. Conversely, when an embankment is artificially formed, a zigzag shape can be created arbitrarily. Sometimes terraces take the form of a rectangular recess. For instance, in Ollantaytambo, the shape follows the slope with a hollow at its base. In Sacsayhuaman, ledges are located right at the center. Surprisingly, this key focal point of the complex remains unfinished in the sense already mentioned earlier. From an anthropocentric perspective, such unfinishedness seems plausible regardless of cultural differences. Some terraces resemble agricultural ones but lack practically any usable area, revealing other purposes for their construction. Here, the universal explanation comes into play, the ritual function of the object. This explanation is often applied when other objectives cannot be identified. This is evident in Ollantaytambo, where terraces built using polygonal facing coexist with larger terraces made of rough stone. Both types can be considered ceremonial. Interestingly, the rough stone terraces occupy central and well-visible positions, which would warrant high-quality construction in the first place. But this was not done. The high-quality terraces are pushed into the background, and is associated with the Temple of the Sun belong to an unfinished structure. Once again, the central point of the complex contains an unfinished object. The scattered blocks are not the result of destruction, but rather of repeated use. Many elements indicate this. These blocks were never utilized further. Construction was left as it was. As we can see, the ritual purpose explanation does not fit due to the secondary nature of placement and size. Moreover, the volumes of masonry in the two types of neighboring terraces are comparable. This means that with the same extent of masonry, varying usable areas could be achieved depending on the slope angle. Constructing high-quality walls with minimal results is irrational and justifiable only if the outcome was indeed achieved, albeit non-agricultural in nature. Terraces are connected to other elements of polygonal complexes. Due to their simplicity and prevalence in South America, approximately 2 million hectares, they appear secondary. However, if one calculates the cost of their construction, these exceed those of building structures by an order of magnitude due to their greater area or simply the sheer number of blocks used. Moreover, the quality of joins, especially on the upper levels, reaches its peak. In Ollantaytambo, terraces once transitioned into building walls, becoming their foundation and an integral part. Thus, terraces are far from secondary elements of polygonal complexes. Moreover, they are an integral part, always located near other elements of the complex. Whereas agricultural terraces are self-sufficient and can exist independently. It is also evident that the terraces, like the other structures, were actively extended, resulting in polygonal ones, some of which are insignificant, being adjacent to agricultural ones that cover vast areas. In Machupicchu, the number of high-quality terraces is not large. Those that exist are in close proximity to polygonal structures. Many sections are constructed without precise joining, similar to the foundation of the Temple of Three Windows. This contrasts with the foundation of the building in Ollantaytambo. According to a master stoneworker, Machupicchu's granite is a very durable material. It is reasonable to assume that processing it required more effort to achieve precise joins. Thus, terraces were built using a simplified method involving partial fitting or filling joints with small stones. Due to varying hardness levels of stone types, the joining surfaces should differ. In the first part, it was stated that the accuracy of fitting does not generally depend on the type of stone. This is indeed true. However, details differ. For instance, joints in the corners of Machupicchu blocks often have gaps. Also, sharp edges are less pronounced compared to limestone masonry. Consequently, the quantity and quality of terraces in Machupicchu are surprisingly low compared to the number of wall niches, and the likely reason is the hardness of the stone. In Urak, also made of granite, there is similarly no emphasis on terraces. A terrace can be thought of as a platform. However, unlike platforms, terraces lack additional elements, which is unusual since we see a tendency to use masonry as a base for niches. There is an example where terraces, constructed using a different technique, contain niches. This deviation from the norms of polygonal construction speaks for itself. Another distinction is that polygonal terraces are constructed with single-row masonry, whereas those made from rough stone often consist of multiple rows. To conclude the description of the terraces, let's take another look at them. These are facings in contact with either rock or an artificial embankment. Their resemblance to agricultural features is observed only when they are arranged in several levels, as in Ollantaytambo. In other cases, the idea of their agricultural purpose does not arise. There is a separate class of objects where the facing contains only parts of niches, forming semi-niches. A typical example is Kilarimiok or Chinchero, where the upper masonry is built in a different style, while the polygonal part is interrupted. Traces of joined profiles on the upper blocks are not visible. It would have been sufficient to cover such a structure with an additional row of masonry, creating a row of rectangular niches. However, the builders chose to leave it in this form, resembling an unfinished object. Here, a clarification is necessary. Using the term unfinished implies that the structure is not ready for conventional human needs, whether practical or ritualistic. However, from a technical perspective, calling it unfinished is incorrect. In this sense, a tuned guitar with the sorted tension adjustments would appear incorrect in terms of organization. But the determining factor here is not appearance. Based on the vast number of structures that seem unfinished, there are ample grounds to suggest that their design goal was not appearance but a specific functionality. Once this functionality was achieved, construction ceased. Therefore, it is likely that all structures are technically complete, remaining as they are. Another possibility is that construction was heavily constrained by certain circumstances and ceased once the minimum requirements were met. Finally, the idea of constant use or worship does not hold, as over several hundred years, construction could have been brought to an aesthetically complete state. Especially since we are often talking about just a few rows of masonry or even a handful of blocks. Thus, the semi-niches of Chinchero are conditionally unfinished. The roofing is absent. Now it becomes clear why, because it was never intended. I will continue to use the term unfinished in the context of the absence of the typical leveling of masonry and the visible readiness for operation that we are accustomed to. A separate explanation is required for the recurring phenomenon, the continuation of construction with partial preservation of style but using drastically different methods. This applies not only to pediments but also to all other elements, walls, niches, and facings. The simplest explanation is that the authorship belongs to different cultures with distinct technical capabilities and construction purposes. Such an explanation faces resistance not only from official science, which relies on excavation data and established chronology, but also from specific facts that must be considered separately. The situation becomes even more complex when taking other regions into account. As a result, single and step semi-niches are observed. They can be conceptualized as bends in the masonry, especially when the foundation has minimal height. In cases where the semi-niches are built on a high foundation, two different objects, the base and the zigzag, will merge into one composition. In fact, niches can be represented in the same way, especially when the foundation has a different angle of inclination. As seen in Ollantay Tambo, it almost emphasizes the separation of two structures. The fourth type of facing occurs when the internal space is partially or entirely filled with a rock mass. Such elements can be found in many complexes, Paysak, Tamba, Mache. Rodadero opposite Sacsayhuaman is another example, but on a significantly larger scale. A rock surrounded by remnants of masonry, a peculiar structure. Nevertheless, the Coricancha complex, if you look at its blueprints, may originally have resembled something like this: several so-called buildings similar to those found in Paysak, Machupicchu, Sacsayhuaman, Torontoy, or Cajamarca, and a wall encircling a rock. It is worth noting here that this element has a technical feature: the contact between different types of stone, rock, and masonry are always made of different stone types. Paysak, volcanic breccia, andesite. Wadadero, diorite limestone. Tambamache, diorite limestone. It can be assumed that the goal was to give the rock certain contours, using the masonry as plaster. However, this could have been achieved simply by removing excess rock, as was done in Kenko. Moreover, leveling the foundation was necessary for wall construction regardless. Therefore, the deliberate goal was to connect different types of stone. This suggests that the structure before us likely has technical and knowledges rather than ritual purposes. At the same time, installing limestone blocks into diorite rock required tremendous effort, removing significant volumes of material to ensure the fit between the block and the rock. This had to be done carefully to avoid damaging the edges or chipping away excessive amounts of rock. To simplify the task, natural cavities were maximally utilized, into which blocks were placed after further refinement. From the outside, this appears to be an attempt to repair the rock by sealing a crack. A similar structure exists in Turkey. One can see traces of block connections left in the rock. Nearby are remnants of polycurve masonry with characteristic features, edges, protrusions, sharp ridges, and high-quality joints. Thus, we are dealing with remnants of a polygonal complex located thousands of miles from Peru. In the discussed element, the masonry does not surround just any rock but only geological intrusions. In Machupicchu's Temple of the Sun, the foundation and masonry are made of granite. This is logical since the rock is not a foreign geological formation but rather resembles a giant block due to its shaping and internal filling. The same situation occurs in Kenko, where both the rock and the masonry are made of limestone. But in both cases, the rock serves as the foundation, the base, and does not fully connect with the back surfaces of the blocks. Thus, despite external similarities, these structures are different. Similarly, terrace facings can fit snugly against the rock base, forming a cohesive whole. Here, it is indeed about giving the rock a certain appearance using masonry. The next type of structure is aqueducts. Virtually every complex is associated with a hydraulic system and cannot be described otherwise. This deserves separate attention, but we will outline the most general features here. The hydraulic structures ensure both water supply and drainage to prevent structural damage during the rainy season. At first glance, this is the only part of the complex whose purpose is easily understood: ordinary water supply for domestic and ritual needs. The water supply can indeed be divided into many functional purposes. Domestic needs, rituals, and uses that are hard to categorize due to specific details. For example, in Machu Picchu, water was brought from a location removed from the complex through a system of sluices, as described in detail in the work of Kenneth Wright. The water then flowed into a series of cascades. The impracticality of this design poorly aligns with the high engineering quality of the main water channel. After all, with a sequential connection, domestic use becomes difficult. Dirty water would fill all lower sources. It would have been much more effective to use parallel connections for the cascades, even partially. Additionally, their number is excessive for domestic purposes, indicating a ritual function. Moreover, the domestic use hypothesis is immediately challenged. If the buildings were not intended for living, there would be little reason to bring water to them except for ceremonial purposes. On the other hand, the ceremonial purpose faces the aforementioned argument of incompleteness. Too little space is allocated for rituals, and their placement is far from central. In contrast, Tambamache features an aqueduct located at the heart of the complex. Yet even here, it is hard to call the site a bathhouse due to the modest size of the supposed buildings and their enclosed doorways. Interpreting the aqueduct in Cajamarca is even more challenging, where the channel runs through a rock for which a ledge was made. Such an element defies simple explanation. It would have been easier to slightly change the direction and bypass the rocky area. Instead, deviations from straightness were unacceptable in one instance, while deliberate curvatures were sought in another. Meanders are also present. These are usually used to prevent water stagnation, and that may be the case here. However, such solutions are atypical for South America. Time and again, complex and unclear solutions are associated with polygonal constructions. In Saxe-Heuermann, water was supplied from a distance. In the so-called Devil's Balcony, there is a polygonal wall directed into emptiness. Below, there was also polygonal masonry. Only a few rows remain, along with marks of joints in the rock. In cases where polygonal constructions are absent, the purpose of the water channels becomes clear and even mundane. Thus, hydraulic systems, like terraces and buildings, superficially resemble standard solutions but upon closer examination cannot be classified within familiar categories. Hydraulic structures can also be categorized based on their water supply principle, from sources active or from rainwater passive. The previously mentioned complexes, such as Machu Picchu, Saxe-Heuermann, Tambamache, Pisek, and many others, belong to the first type. The second type is not always noticeable. These structures are small and function only during rainfall. Examples include the water channel inside a building at Machu Picchu or the depressions in the rock foundation of the Temple of the Sun. Huacas in the surroundings of Cusco show no traces of water supply, yet hydraulic construction elements are present. Sometimes, geometric carvings include depressions of regular shapes, some of which are of natural origin and were deliberately preserved. These serve to collect rainwater. A closer examination reveals that water flow might be a key element of polygonal complexes. Any other elements may be absent or represented by small structures. However, water always occupies a central position, not water itself, but a specifically regulated movement. The presence of a waterfall, traditionally referred to as a fountain for some reason, is mandatory. In most cases, this element is designed as a large block with the channel featuring a protruding section. Unfortunately, many water channels have undergone significant reconstruction and modifications, both in ancient times and in the modern era. Examples include Serewite Pisek or Rumikalka. In other cases, hydraulic systems have been destroyed. At Ollantaytambo, near the Temple of the Ten Niches, only episodic elements remain. Thus, in-depth analysis of hydraulic structures is highly challenging due to the inability to determine their original state. Another element of polygonal complexes is a section of rock or a stone boulder with an inclined vault, Machupicchu, Kilauea, Napa Igulda, Kalme, Temple of the Moon in Tiwanaku, Ramimakawasi, Kenko. Often, the surfaces of the rocks show no signs of processing. In Machupicchu, however, the surface was likely adjusted to form a step. How this was achieved remains unclear. Natural cracks might have been used, but the rock was removed layer by layer. The resulting cavities were filled with niches into hiratanes and geometric carvings. This type of structure can be called a configured grotto and compared to a building maximally integrated into the natural environment. The key difference is their saturation with other elements. In buildings, stone configurations are not explicitly present. They seem to be hidden, such as small rock protrusions or specially treated sections. This category also includes megaliths placed at the base of walls. It's hard to assume that the skills and abilities to process stone were insufficient to remove protruding block parts that reduced free space. Moreover, megaliths could have been shifted to protrude outward. Since this wasn't done, it means the decision was intentional. Such elements can, of course, be used for practical purposes, but only if the buildings themselves were used for residential purposes. This is exactly how one of the buildings in Machupicchu was repurposed, which possibly also contains a water channel inside. However, such a solution is impractical because the stone still requires a wooden covering, which could have been installed on a less massive foundation. Protruding geometric elements between niches should also be categorized as intentionally designed. They belong to the same class of elements as other block protrusions. Through reuse for roof attachments, they have become something ordinary and unremarkable. In their standard form, they differ from knobs, which are tied to the block itself. Geometric protrusions correspond to structural elements of buildings and belong to a different class. The fact that buildings and objects were entirely artificial allowed for maximum control of necessary parameters and extensive standardization. Thus, through symmetry and rectangular shapes, walls of niches exhibit similarity among themselves. In contrast, in a configured grotto, the only standard is the presence of an inclined vault. Everything else is situational, a fully open side or a shaped opening, small or large niches, with or without geometric protrusions. Another difference is that in buildings, the covering of niches is aligned to a single level, while under a boulder, niches have varying heights determined by the slope of the rock. The type of structure at Urukrumi becomes clear. It's a row of half niches extending beyond the rock. At the same time, its style differs from other complexes and is unique. The next element is notches in stone with specific geometry. Researcher Vladimir Pyatkin introduced an appropriate term for configurations because these notches have precise geometric configurations. Their quantity and size can vary significantly. Sometimes these objects are the primary part of the complex, like at Pumaorco. Here, the walls are minimal, or, as in Machupicchu, the main part of the complex is wall's niche, and the configurations are scattered with only a few in number. At Urukrumi, these configurations are significant, while walls are absent, and the number of blocks totals only a few dozen. Configurations can be divided into several specific types, but we won't address this now. It's sufficient to note that such elements are present in any complex and occupy a central position. It should immediately be clarified that configurations cannot be associated with quarries due to the small volume of extracted material. They also cannot be linked to training grounds for stoneworking education because these are not chaotic objects but structured ones, united into a whole, just like masonry blocks. The last component is caves and underground cavities. Literally, every complex in the vicinity has an entrance to a cave. This is the least studied element, one could even say entirely unexplored. Access to these objects is often closed due to the risk of collapse or the complex systems of passages where one can easily get lost. There are claims that at least neighboring complexes could be interconnected by underground tunnels. For instance, according to geodetic surveys, there is a cavity beneath the rock with configurations at Chincana Grande. During restoration work in Cusco, a section of a structure resembling a tunnel was uncovered, aligning with the direction of Sacsayhuaman. These observations provide grounds for speculation but no definitive facts. It is also known that some complexes are aligned along a straight line. In this case, one should consider certain global scale parameters determining the location of these complexes. A separate group is represented by objects outside of categories, where a structure exists as a single instance. Such an example is the conditional Rumikok gate. It could be mistaken for a platform. But there are no wall niches or configured grottos in the surroundings, which are always associated with facings. The Raksha columns also fall into this category, some of which feature through openings. A resemblance to such structures can be observed in the reconstruction of Saxe-Human. However, here they stand alone, with no other polygonal structures nearby. Alan Tetamba, the Temple of the Sun. A unique combination of megalithic walls and polygonal masonry on the rear side. This structure is atypical but has some recognizable features, and it will be given separate attention. The remains of the Saxe-Human Tower. 3 concentric foundations connected by crossbeams. It is highly likely that the construction is largely inauthentic. According to archaeological reports, it represented a water conduit system with a central reservoir in the middle. This is also evidenced by numerous stone channels. The Q-symbol chalpas with niches, which give them a resemblance to a building. Nevertheless, the chalpas stand alone without other components. However, in this case, other elements might have been dismantled and did not survive. Such a fate has befallen many complexes, only piles of stones and some preserved sections remain. The perfection of masonry craftsmanship resists nature well. Constructed according to its principles, polygonal structures essentially become a part of nature. But they cannot withstand intentional destruction carried out by human hands. Each of the reviewed structures outside of categories is no exception. The rules for creating polygonal elements are generally not violated. However, it is necessary to speak of excessive individuality, which is why there is nothing strictly similar among the complexes. As mentioned in the analysis of buildings, fully identical structures do not exist in principle, just as there are no exact copies within the same species. And the elements of complexes, drawing an analogy with biological systematics, belong more likely to the same genus or even family. Therefore, the resemblance becomes even more distant. Summing up, a polygonal complex can be represented as a combination of terraces, configurations, wall niches, configured grottos, platforms, hydraulic systems, and facings. These elements are not isolated from one another but form a single whole, transitioning from one to another, touching through walls with special sections of masonry, like pathways on a printed circuit board. Buildings connect to each other or to rocks, terraces transition into buildings. Likewise, the facings of terraces incorporate rocks, literally embracing them, while simultaneously touching the edges and curves of the terrain. And all of this is interwoven with water conduits. The elements of a complex can also be spaced apart. Primarily, this applies to water sources. As already mentioned, they may be located at a distance. The same applies to other structural elements. For instance, in Pisac, the facing surrounding the rock is located at the center of the complex. In Tambamache, it is at a short distance. The Rodadero of Saxe-Human, an object of the same type, is much farther away, but the complex itself is larger in scale. In Kenko, the massive rock with numerous configurations is within Saxe-Human but at a considerable distance. In Inkotambo or Chinchero, these objects are within the complex. At the same time, the elements themselves are not standardized, and their relative size within a complex can vary greatly from place to place. Polygonal terraces can be episodic or extensive. There may be several buildings, one, or none at all. Niches can be large or small, and a platform may include niches or not. Configured grottos may be entirely absent or take a central place. Literally, every element has variations. Even in art, styles have their boundaries. All the more so if rituals are involved. Such variations are permissible only if the created object is meant to interact with the existing environment. For instance, the bridge must embody a specific idea while taking existing conditions into account. The same principle is observed here. Each specific terrain feature, rock outcrop, or water source is adapted to by a corresponding structure. This explains the diversity in the design and arrangement of elements, the fact that decisions were made during the construction process, and the unfinished nature of some structures, which were later supplemented and extended. Because adaptation is not an instantaneous process, just as construction is not. Clearly, some structures are foundational and require little adjustment, while others must be finely tailored to meet their specific purpose. This is evident when a smaller structure is added to the main temple of Machupicchu, mirroring its design. Even the niches are proportionally aligned. Moreover, the extension is seamlessly joined to the original structure, forming a unified whole. They are, in fact, one entity. However, to adapt something, one must have a clear understanding of the initial parameters. For a bridge, these parameters include the features of the terrain that determine its length and height. Other considerations include load calculations, both permanent and temporary, as well as wind, seismic activity, thermal effects, and so forth. Based on these factors, an appropriate design is chosen, ideally one that has already been tested and proven over time. The choice of design is undoubtedly influenced by financial and resource constraints. However, in the context of South America, these factors of secondary stone was abundant and financial considerations were irrelevant. But what data can we extract from the terrain or a massive rock? Of course, we can determine its geometric parameters and some physical properties, average density, mineral composition, thermal conductivity, etc. But how does this relate to the construction of masonry? For us, it doesn't unless we are investigating the foundation of a future building. However, the creators of polygonal structures were undoubtedly adjusting something accessible only to them. Some rock was removed, certain cracks and voids were filled, while others were deliberately created in the form of niches. The result was a form of organization and adaptation. How permissible, then, is the introduction of a proximity to rough stone structures in such cases? Not only do they look unaesthetic, but they also seem unnecessary, like sand inside a bearing. Could the creators of polygonal construction have done such a thing? No. This violates the very essence of their approach. It might be acceptable to construct something in the vicinity of the distance, but not within the complex itself, and certainly not by altering the design, for example, by adding a roof. There is no doubt that those who created polygonal complexes from thousands of precisely fitted blocks could, if needed, construct a roof without resorting to rough stone, mortar, and reeds. The result of their construction, whatever their purpose, was something autonomous. No moving parts, no maintenance requirements. Well, almost none. The only movement is water, which still flows in some complexes to this day, hundreds of years after their creation. Such durability is enviable. But it is not surprising. Using natural properties with minimal alterations and avoiding destructive interventions is the key to reliability. A physicist would observe that connections between the structures and elements of the complexes and their natural surroundings were made through stone and masonry. The only thing stone effectively conducts is mechanical waves. Thus, niches may function as modulators, where vibrations circulate along the walls of a building, while openings sometimes break the circuit. This process is only possible with seamless connections and minimal gaps. And a physicist would conclude that perfect fitting is not merely an aesthetic requirement, but a purely technical one. A geologist might note that in Machupicchu, studies have identified specific frequencies within the seismic noise. Intrusions, meanwhile, serve as clear markers of local geological activity. The physicist would continue, noting that the cladding of intrusions with polygonal masonry is logical. In hydraulic structures, the waterfall plays a key role, serving as an additional source of vibration linked to its separate elements. In a configured grotto, modulating niches are often connected to a boulder that has frequently been shaped to a specific geometry, altering its natural frequencies. The chemist would recall the stone's ability to absorb moisture, which affects many of its characteristics by filling its pores. This makes roofs unnecessary. Moreover, positioning buildings in a certain way relative to the sun ensures that even the slightest thermal expansions inherent to stone will tighten the joints more firmly. The selection of specific masonry patterns, therefore, is not coincidental. An electronic specialist would point to analogies between the circulation of current through printed circuit board pathways and the winding layouts of buildings and foundations. The historian would note that all of these aspects align perfectly with the beliefs of the Incas, where the integration of buildings with a sacred rock was commonplace, and the orientation of structures toward the sun was essential for astronomical observations. The architect would point out that joining buildings to the rock is a standard solution for strengthening the structure. A biologist, using analogies, will note that the principles of a system maximally integrated into its environment will resemble natural solutions, such as an airplane wing or a soma. An engineer will observe the differences in principles. Our technologies transmit or transform energy from one form to another, using artificial materials ranging from metals to semiconductors. For instance, an internal combustion engine converts thermal energy into mechanical energy. By connecting it to a generator, mechanical energy can be transformed into electrical energy. An ecologist will draw attention to the fact that we use the laws of nature but ignore ready-made energy resources. Even power plants of all types are only a partial exception. Hydroelectric or wind power plants convert the mechanical energy of water or wind into electrical energy. Solar plants do not even transform the type of energy, only its form changes as radiation energy is delivered to the consumer as an electric current via the photoelectric effect. The engineer will continue by stating that polygonal complexes are fundamentally different. Here, we see the use of all natural phenomena: seismic, hydrological, solar energy, and even rain. Moreover, there are no fully artificial components. There are no traces of equipment. Even if it had disappeared, traces of fastenings would remain. There are only rocks and masonry consisting of natural stone specifically selected for its types and characteristics. In some cases, the required stone was transported from dozens of kilometers away. I would argue that all the interpretations listed contain contradictions or incompleteness. Therefore, they should be regarded as a dataset rather than ready-made answers. For instance, the idea of wave propagation processes ends abruptly at the question of purpose. What is the final result? What is it all for? The historical version, in its canonical form, does not account for all the elements of the complex. The biological analogy is merely that, an analogy. Furthermore, living organisms evolve, whereas the forms here remain unchanged. Only the system states can shift. Regardless of the perspective on the purpose of polygonal complexes, whether ritualistic or technical, we can confidently assert that we are dealing with a complex system. But who is the consumer of the final processes? Perhaps the purpose is indeed ritualistic, but in a broader sense, when not only the ritual itself is implied, but also the use of auxiliary equipment. For example, the rhythms of musical instruments can lead participants into a trance. The goals of rituals can vary, invoking the heavens or transitioning into an altered state of consciousness. In the first case, no special equipment is required. The ritual itself and the chosen location are sufficient. In the second case, additional methods are actively employed, from instruments to specific foods. Here, we step into uncharted territory. Altered states of consciousness are being actively studied, as are the causes that provoke them. One of these causes, the influence of the natural environment, is almost impossible to study due to its instability in both manifestation and effect. The good example is the dolmens of the Caucasus. Numerous accounts indicate that on certain days, electromagnetic phenomena occur near the dolmens, compass needles deviate, electrical devices and equipment malfunction. Cases of memory loss and brief confusion have also been recorded. However, studying this phenomenon is nearly impossible. One of the most critical parameters of an experiment is its repeatability and stability. Not every person experiences similar sensations, and electromagnetic manifestations are unpredictable. This complicates research, making it costly and unpromising. Thus, isolated incidents near the dolmens are often dismissed as rumors or coincidences. Could it be that polygonal complexes were built for ritual purposes, with a technical perspective in mind? This would be a beautiful theory. A certain culture, using subtle natural fluctuations, amplified them to tune consciousness to a specific state, such as enlightenment or hypersensitivity. Such a hypothesis could be meaningfully linked to the temples of Cambodia and India, as well as the monumental structures of Eastern culture. Moreover, this version fits well within the framework of accepted traditional explanations. However, a contradiction arises. If we accept a polygonal complex as a construction with a specific technical purpose, then it requires an understanding not only of architectural principles but also of the workings of consciousness and the natural factors associated with it. Perhaps such knowledge could be accumulated over hundreds or thousands of years, as was the case in the East. However, in South America, polygonal complexes appear suddenly. This discrepancy spans two levels at once. On the technical level, where did the skills, tools, and deep architectural knowledge come from? On the biological level, how did an understanding of certain natural phenomena and their connections to cognitive processes suddenly emerge? The only way to resolve this multitude of problems is by introducing certain knowledge from an external source. This is exactly how science operates. There is a viewpoint suggesting that the Incas acquired their stoneworking skills from the Tiwanaku culture. We will return to this theory later, where we will also explore how polygonal technology evolved. In the next episode, we'll discuss the principles followed by the creators of polygonal complexes. Thank you for watching and supporting the channel with a like or comment. See you next time.